GPUs, TPUs, NPUs, these are some of the most important chips powering AI right now, but what actually makes them different? To understand that, you need to understand one thing first. Modern AI is basically doing an enormous amount of matrix multiplication, again and again and again. Neural networks take huge grids of numbers, multiply them together, add the results, and repeat that process billions of times. The difference between all these chips is mostly about how specialized they are for doing that math. Let's start with the CPU. The CPU is the general-purpose chip inside almost every computer. It has a relatively small number of very powerful cores designed to do almost anything. Run your operating system, open a web page, execute some code, respond to your mouse click. A CPU can absolutely run AI models. The problem is that neural networks need the same kind of calculation performed across millions of values at the same time, and CPUs simply weren't designed for that level of parallelism. That's where GPUs came in. GPUs were originally built for graphics. To render a game, your computer needs to perform similar calculations across millions of pixels simultaneously. So instead of a few extremely powerful cores, GPUs have thousands of smaller cores working in parallel, and it turns out that architecture is incredibly good for neural networks too. That's why GPUs became the dominant hardware for training and running large AI models. But GPUs are still fairly general purpose. So what if you build a chip specifically for AI? That's basically the idea behind Google's TPU. TPU stands for Tensor Processing Unit. Instead of being designed for graphics first, TPUs are optimized specifically for the tensor and matrix operations used heavily in machine learning. One important design is something called the systolic array. Imagine a huge grid of tiny calculators. Data enters the grid, moves from one calculator to another, and gets reused along the way. Instead of constantly going back to memory for every operation, the data keeps flowing through the chip. That reduces memory movement, which is extremely important because moving data can sometimes cost more time and energy than doing the actual multiplication. Now, what about NPUs? NPU stands for Neural Processing Unit. These are also specialized AI accelerators, but you'll often find them inside phones, laptops, and other edge devices. Here, the problem is different. You don't have a giant data center with thousands of watts available. You have a battery. So the goal becomes run AI locally while using as little power as possible. NPUs are optimized for efficient neural network operations, often using lower precision math that AI models can handle perfectly well. That's why your phone can do things like face recognition, background removal, camera enhancement, speech processing, which are even run smaller generative AI models without sending everything to the cloud or destroying your battery. So the easiest way to remember this is CPU, general purpose computing, GPU, massive parallel computing, TPU, highly specialized machine learning acceleration, NPU, efficient AI acceleration, especially on edge devices. And there are even more acronyms appearing now, LPUs, VPUs. But almost all of them are chasing the same goal. Take the math AI uses the most and build hardware that can do that specific math faster, cheaper, or with less power.